So we are dealing with the 12th problem in this series, and the 12th problem is problem number 1.89. The problem is suggesting a cyclist rides along the circumference of a circular horizontal plane of radius r, the friction coefficient being dependent only on the distance small r from the center O of the plane, and it is given as mu equals mu naught 1 minus small r by r, where mu naught is a constant. Find the radius of the circle with the center at the point along which the cyclist can ride with the maximum velocity. What is this velocity? So let us begin this problem. So in this problem, the only thing that is intriguing is that the value of coefficient of friction mu equals mu naught 1 minus small r by r. So this value of coefficient of friction is varying with distance r from the center O of the plane, and obviously for the equilibrium of the cyclist, for the equilibrium of cyclist it is important that the force mv square by r is balanced by frictional force, and frictional force will be equal to mu mg, which is the normal reaction force. So if we equate them, so m and m cancel, we get v square upon r equals mu into g. Mu can be written as mu naught 1 minus r by r times g, and therefore the expression for speed that we have is mu naught r minus r square by r g root over. So this is the expression for speed that we have. Now the problem is asking us find the radius of the circle with the center at the point along which the cyclist can ride with the maximum velocity. So we have this expression for velocity, but the problem wants maximum velocity. So if we equate, if we maximize this function, so this function of r is to be maximized. Therefore for v to be maximum, we have this function of r, that is r minus r square by capital R. Everything else is a constant. If we differentiate this, that is if we calculate f dash r, that is we differentiate this with respect to r. So derivative of r minus r square by capital R, so we get 1 minus 2r by r, and we equate this to 0. So we get small r being equal to r by 2. So for r by 2, the maximum speed can be calculated, and hence the maximum speed v maximum equals mu naught r by 2 minus r square by 4r g root over, and on solving we obtain this as half of root over mu naught rg. So this is the point where the speed is maximum, and this is the maximum speed, root over mu naught rg by 2. And this was problem number 1.89.